All right, so we'll do one more example here. And of course, we notice this is a degree 3. This is a degree 2. And so they differ by just one. It's top heavy. And so this is going to result in an oblique asymptote, or a horizontal or a slant asymptote here. So we're going to divide these using polynomial long division this time. We can't use synthetic because the denominator is not a linear term. All right. And we're only interested in the quotient up here. We don't really care about the remainder, all right? So x squared times what will give me x to the third. That'll be an x. Then we'll do x times both of those. X times x squared is x to the third. X times 1 is 1x. All right, subtract these. That minus that is 0. Then we'll bring our negative x squared down. Negative 4x minus x, negative 5x. Bring our 1 down. X squared times what will give me negative x squared? That'll be a minus 1. Now the rest of this, I'll go ahead and do it, but we actually don't need to. This is our quotient that we're looking for. So negative 1 times x squared is negative x squared. Negative 1 times 1 is negative 1. Subtract, and you'll get negative 5x. 1 minus negative 1 is a 2. So this is going to be our remainder. And the reason we know this is our remainder and we can stop is because the degree here is lower than the degree of our divisor. All right. So this x minus 1 is our slant or oblique asymptote. All right. So let's go ahead and look at the graph here. All right. So we can see that it's doing, something pretty predictable off to the right and on the left. So those are the asymptote that we're after. So if we graph y equals x minus 1, which is what we found it to be, we'll see that they are neck and neck. They're completely parallel to each other. Off to infinity, you can't tell the two apart. All right. If we're looking at our range, this one's actually kind of simple. It doesn't really blow up towards infinity anywhere. So it goes, negative infinity here. It does a couple of squiggles here, but it's completely continuous. So it goes from negative infinity to infinity. All right. Range is kind of easy on that one.